Language integrated query is a collection of language extensions that allow us to iterate through collections of data. And as a set of language tools, I can operate against any collection from whichever language I'm looking at, from Visual Basic, C#, even C++. Originally added in .NET 3.5, LINQ is a way for going through and iterating through collections of data that use a common SQL-like syntax where we've got from clauses, select statements, and we've got where clauses. Each of these different components of the language allow us to go out and specify, and developers who are familiar with SQL will find that LINQ is a great way to extend your skills to this development environment. It also includes things like joining, grouping, ordering. We can do aggregates so that in my queries, I can actually write queries that are going to go through and pull back the maximums and minimums. But I can do a lot with shaping what that data is going to look like and grouping it and creating a return set out of an input that will meet exactly what my needs are. Some of the other things I can do with LINQ is I can also handle things like the number of records to be or that are affected by it with a count, or I can do a skip, or I can do a take. This works with implicitly typed variables, anonymous types, and lambda expressions. And really, to understand how all this fits, I mean, there's a lot of parts that make that work. LINQ makes extensive use of generics. So using things like the iQueryable and iEnumerable are interfaces that define out a collection of data. And those interfaces then have features that allow us to go out and add select clauses and iterate against those generic types. It also works on a number of language features, things like type inference, where I can go out and I can, in compile time, be able to infer what the resulting data type is going to look like. And I can use an anonymous type to actually describe it that might have however many properties I want and have the different data types already defined. It allows us to work with lambda expressions, which are ways of describing a collection of code that I want to run against a data set. So for instance, I can say in very succinct language how I want to operate on the contents of a query. When I look at a LINQ query expression for the first time, I might start with a SQL statement and then convert it. So if you're familiar with SQL, you've got a select statement where we're going to pull from someplace, where some criteria match out, and then order the result set. And this syntax is very similar to what a LINQ statement is. If we were to translate this to LINQ, we would find that the first thing that we're going to do is we're taking that select statement and we're going to put that last. The reason why is that until we know where we're going to be getting the data from, it's hard for us to be able to specify that. So the first thing is that we have this thing called a var. Var, today's birthday. What var is it's a implicitly defined variable that will take its type based on what comes on the right-hand side. On the right-hand side, we have the select new, which is an anonymous type, and then we have two columns, which is going to be my full name and then my age. The second thing I'm going to do in a LINQ query is I'm going to say where I'm going to get my data. I'm going to pull it from C in db.customers. I'm going to pull back a collection, db being some database where my customer table lives. And I'm going to have some where clauses that are going to go through specifying exactly what I'm looking at. So instead of saying where birthday is equal to getDate, I can use in C#, I can use datetime.today. And then finally, we've got the order by clause, which is going to come in and actually iterate through the collection in a particular order. Now that LINQ query expression has got some projection where we select out what we're going to look at. We have some filter where we're putting in the where clause. We can use distinct. We have ordering. We have aggregation. We have a lot of processing that we can do to go through and iterate through a set of data. The nice thing about this is that this query expression then will actually go through a LINQ provider to give us a result set. The way that that works is that given our application and some statement, a LINQ statement where we want to pull back that collection, the application goes to the LINQ provider to enumerate through the collection, which then the LINQ provider emits a bunch of SQL or data-specific statements to iterate through the collection. For a link to SQL, for instance, it's going to create a SQL statement. So it translates the link statement into that, which then returns back a collection back to the provider, which then expands that out into a collection of objects. All of those objects are then going to be used by the application to go out and do things. It might do some inserts, updates, deletes, changes. All of those changes are going to be maintained inside of the application, inside of a cache set of data, which then by going out and calling a submit changes, it'll actually go through and emit a bunch of data manipulation calls. For instance, inserting, updating, and deleting from the customer database. There's a number of different link providers, and when people think of link, they generally think of in terms of database, but it also works against just any kind of object that implements the IEnumerable collection. We can also use it against XML and use it to generate and work with XML environments. We can work with SQL. We can work with just about any provider. Let's take a look at some examples. So let's dive into LINQ, Language Integrated Query. I've got a project out here where I've got a simple ASP.NET page. If I take a look here, you'll see there's my default page. On it, I've added a grid and a little bit of text. If I take a look at the source, you'll see it's just a simple ASP.NET page. The thing that I want to do is I want to iterate through and look at how we can use LINQ to look at data and work with it inside of our applications, because data is really centered in everything that we do inside of building software. So in our class, I want to go out and do the classic, let's go out and see how we can bind to something. Suppose I've got a class called, for instance, people, where I've got a person object, which has got a name and an age, and then we got a class for people, which contains a list of persons called my people. In our application, if I want to take my grid and bind that out to that list, I can go in and I can say var my people is equal to from p in, and then I'm going to go out and create a new people collection, and I'm going to call the get or my people, and I can say where p, and then I get IntelliSense against that class object. So the nice thing about LINQ is that I'm using a strongly typed data set. So as soon as it goes out and pulls back the my people, which is a collection of persons, it knows that there's an age property and a name property and a few other things that I might want to work with. So maybe I'm just looking for people who are, say, older than, say, 18, and I'm going to say order by p.age, and I can go out and say select p, and it will return back a collection of these people objects from that static data set. Then I can come down here and I can say my grid view 1, and I'm going to set my data source is equal to my people, and then I can say grid view 1 dot data bind. And if we run this, what we'll find is that this is going to go out. It's going to take this collection of data, and then it's just automatically going to bind it right up. So I can see here's the list of people, and I could even add maybe a criteria on here, maybe a drop-down list that has where the people are older or younger than a certain age. If we wanted to do that, we can go back over here to our page, and let's add in here a drop-down list. And I've got this right here. And we're going to say select age. And what we'll do is we'll say select age, and we'll pull people who are younger or younger than that age. So then we can say where this is equal to the drop-down list. We could put in some different values and be able to tie it in. So so let's do this. Let's go back over here into my default, and we're going to add some items. So edit the items here, and we'll say add a bunch of list items. We'll say the value is, say, 60, 50, 40, 30, and 20. And so we've got a drop-down list. We'll enable the auto post back on it. inside of our drop-down list, what I'm going to do is I'm going to say where people is less than, say, drop-down list 1 dot selected item, and I'm going to do an int.parse on that because it's going to have to do that. And if we run the project now, this is going to pull back people that are younger than whatever that list is. So by default, it starts out with 50, 60, 40. Yep, and it's actually pulling people older than the age, but let's go ahead and fix that. So what we'll do is switch this, and we'll stop this. And now when we run it, I have people less than age 20, less than 40, less than 60, and we can see that as we change that age, it's now binding to different things. Now, binding against collections of our own objects, that's fun and that's fine too. But we could also bind to other things. Let me do this. I'm going to take this, I'm going to say bind data, and I'm going to do a control period to do this, and let's actually take this out and say refactor this out into a method, say bind people, and we'll take bind people and put it in here. So we can go out and we can connect up to that. We could also, if we wanted to, connect to other types of objects. For instance, I might have a collection of system objects that I want to look at. Say I've got my network is equal to from n in system.net, and I'm going to go to the network info, and I'm going to pull back my network interface, and I want to say get all network interfaces, and I'm going to go ahead and say select n, and I'm going to say grid view 1.data source is equal to my net, and I could also do data bind. And if I run this now, instead of doing the bind people, it's going to go out and it's going to bind to the network. And so we can run this, and now it's going to iterate through and show me all of the network interfaces on this machine. Could also go out and connect up to other things, like for instance, suppose I wanted to take a look at database data. I have a data model sitting here called model1.edmx, which has actually got some information about events and presenters and scores and stuff like that. So if you want to work against data in a database, that's also just as easy as this. Let's take our method down here. I'm going to collapse that down. Let's take this, and I'm going to refactor this out to say bind network. But suppose I want to go out and connect up to a data source. I could say var dc is equal to a new demo data context, which is the database connection. And I can say var my events is equal to from e in dc.live events, and I could say where, and I could have e dot, and then I've got all kinds of information about this. So for instance, I could take where my presenter contains Benko, and maybe I can then go through and say order by e dot start date, select E, and I can go grid view dot data source is equal to my events, and grid view 1 dot data bind. And now when we run this, it's going to go back and pull all the events where this matches out to the database, and it's going to pull back all of the events with the name of Bankovich. And let's do this, my events.toList. There we go. But maybe I want to do something that's not necessarily just going against the database, but maybe is going against a collection of files. And maybe I want to pull back do link to a collection of files. In our dropdown, instead of doing a pick an age, maybe what I want to do is select a file. So let's change this to be file. And let's take this and let's just get rid of all the items. And what I'm going to do is I'm going to create a binding where we can use link to go against a collection of files. So I'm going to say if not is postback, then I'm going to go out and call bind files and do a control period to open up the method for that, generate this stub. And what I'm going to do is I'm going to go over here and I'm going to say var di is equal to a new directory info object, and I'm going to path this out to c \data, and then I'm going to go out and say var my files is equal to from f in di.getFiles, and then I want to path in star.xml, and then I can put in some search options saying all directories or just top directory. We'll just pull the top directory only, and I'm going to say select f. I want to bind this to the drop-down data list, so I'm going to take my drop-down data list 1, and I'm going to set my data source is equal to my files, and then I'm going to do drop-down data list data bind, and then that will go through and actually bind this up to that list. But before I do that, I'm also going to set the display member text and the actual values. So the drop-down data list 1's.display data text field is equal to name, and my drop-down list 1's data value field is equal to full name. So in the collection that comes back from my files, it's going to then populate that. Then, if it's not postback, once we've bound to that list of files in this directory, then I'm going to come in here and I want to actually go through and iterate and work with it. So before I come down here to set this up to my events here, let's do this. I'm going to say, let's do a little bit of linked XML. So in XML, I've got in my data directory, just to show you what this looks like, on my C drive, I have a bunch of XML files describing a collection of venues. So if I were to take a look at this, you'll see that I've got a location, for instance, in Albany, where I've got a bunch of attributes. So I've got information about the location venue, the city that it's in, the address. I've got some capacity information, so I can say this one's got a capacity of 500, this has got 1,000, 300, down to 50. And with all of these different XML files, I've got some data that I want to join into the list of events so I know where I want to put my event. So what I can do is I can actually go through and I can parse that XML by going out and creating an X document, which is using the linked XML objects to load the file that is going to come in from that selected value. So when I go out and select a file, it's going to go through and bind to it. Now I've got a schema for the namespace on where those events live, and I'm going to go into the XDoc where I've got the root elements for the namespace of location, and I'm going to pull back the name of the city, the capacity, the name, and the address. And if we change this to be my X venues, and we run this, I can actually go out and see what's the contents of these different files. So there's a city. If I go to Columbus, There's Dallas. You'll see each of these files has a different set of capacity for the city, for the venue, and the address. Now, what I'd like to do is to bind these cities and venues into something that talks to my events. So what I can do is I can go out and I can join different sets together using link. And so we can do this using a join query. Let me go through and actually paste in a query that's going to actually show us what we've got here. So first of all, let me back up, and I'm just going to pull in where the event is an MSDN event. Type. And then I'm going to come down here, and we're going to put in a joined query. And in the syntax I've got over here in this, we'll pull that in. And I've got this coming back, and I'm going to say int.parse, and I'm going to take this and parse in that value. And we do the same thing for this. And then what this is doing is it's going to take our data set from the XML document, the venues that we go out and select from the link to files that gives us the list of files, pull up the document. We're going to join that to my event table. And I'm going to say where the event is equal to E, and I'm going to set the city to match out to the city in the XML to the city in the database. And I'm just going to go ahead and get rid of this capacity so we can see how this is connecting up. But then we've got a start date, and then we go out and are projecting out a new result set that's going to have the city name, it's going to have the ID of the event, the start date, venue name, capacity, the registered quantity, the number of seats available, and also a status on all this. And I'm going to take this and we're going to come out to our joined as my result set. So with this, where we're now going out and we're joining up the link to database to my link to XML into a joined data set, we can run it. And we can see that now it's going to pull back the city. We can change to a different city, Dallas, Columbus. Etc. And I can then iterate through the whole collection of events and data. So, for instance, under the venues, it'll go back out then and select all the venues that match to the barn and various things. So this is using link, and it demonstrates that the language integrated query, or link, is a core part of the .NET framework, which we can use for iterating through and working with data.